I'm back. Let me just set up here. Second part of the assignment. So now we're starting at question number 10. Good, 10. All right. I have a function. I'm writing it down. You should write it down. I'm told the first derivative is negative 4 x plus 1, x minus 2 squared. And it says find the relative extrema and points of inflection and graph f. Okay, here we go. Let me show you what I'm going to do. And you have to graph it at the end. A little sketch. Here we go. So, right away, one of the things I'm looking at is what the critical numbers are for the first derivative. So you can see that negative 1 makes it 0, positive 2 makes it 0, and there's nothing that's undefined. So we're going to start there. So from negative infinity to negative 1 to 2, and 2 to infinity, we're going to do our first derivative number line. We want to know where it's increasing and decreasing. So I want you to plug in a number into here that's less than negative 1. So let's say you pick negative 2. That'd be a negative times a positive. So you can tell that that's going to be increasing. Pick a number between negative 1 and 2, like 0, and you get a negative times a positive times a positive, which is negative. Then pick a number bigger than 2, like 3 or 4. You get a negative times a positive, which again is negative. So this is not a turning point because the signs don't change. But this is. So it increase and decrease. So we have a relative max at negative 1. And then I go back here with negative 1 and then find the y coordinate. So negative 1, negative 1, negative 1. If you did that right, you would get 13. You can do that on your own. There is no minimum, and I can see where it's increasing and decreasing. I want to find the second derivative. So the first derivative would have been negative 4x cubed plus, I don't want to do this. I don't want this one. I'm going to do the first derivative on my own, then the second derivative. Okay, so plus 12x squared minus 16. The second derivative would just be minus 12x squared plus 24x. So I got the first derivative from the expanded form, and then I did the derivative again, equal to 0, and I'm going to factor this. So I'm going to factor out a negative 12x, and I get x minus 2. So the two answers are 0 and 2. So negative 12x gives you 0, and x subtract 2 gives you positive 2. So those are my critical numbers for the second derivative. So to do a second derivative test, I have 0 and 2, and into the second derivative. So plug in a negative number, and you get a negative and another negative. Plug in positive 1, and it's positive. Plug in positive 3, or 4, or 5, or a billion, and eventually this will be 2 next. So you have a negative, a positive, and then a negative. This is concavity. So where it changes is called a point of inflection. So we have 2 points of inflection, 2 places where it changes. So at 0 and at 2 are points of inflection where the concavity changes. So if I plug 0 in, 0, 2 is a point of inflection. And then I do the same thing for 2. Plug that in here for the y value. And 2 gives me negative 14. You'll have to trust me. So to find the y value, you can take your time, plug in, do what you need to do. And now we're ready to go. So I'm going to graph this using those points. So what points again? So I'm going to use negative 1 and 13. Let's say that's there. I'm going to use 0, 0, and 2. I'm going to use 2 and negative 14. So I'm just sketching it. So those are my points I'm going to sketch. Then what am I going to do with that? Well, I also need to know end behavior. So if you look at the end behavior of this, know it's negative x to the fourth. End behavior. Both ends are going down. So this function is going to increase with a frown. So increase with a frown. Let's put them right beside each other so you can see it. So we're going to follow this guide. This is a map to our graph. So the first derivative is going to increase with a frown. And I'm not going to worry about the x-intercepts. So it's going to increase with a frown. And then after 0, after -1, it's going to decrease. Still frown to 0. So decrease, still frown to 0. So there's the first part of the graph. So it frowns to 0. It increases, then decreases. There we go. After 0, this is the second derivative. It's now going to smile, but it's going to keep going down, down, down. So the whole thing is down. It's got to smile, and then frown, and you have it. So concavity, increasing, decreasing. Point of inflection, 2 of them, and a turning point. There's your sketch. All right, number 11. Find the relative extrema and concavity of that. So let me write that down. That's number 11. So for the relative extrema, that's the turning point, the relative maximums and minimums. Take the derivative. Know the domain here is all real numbers. So 2/3, when you cube root and square all numbers, there's nothing that's undefined. So beware of that. It's continuous all the way through. Take the derivative. 2/3 times 3 gives me 2. Subtract. So 2 take away 3 is -1/3. Derivative of -2x is -2. So I'm going to write this better so that you can see it. So that negative exponent means it goes in the denominator. So if I want to find my critical number, 0 is a critical number because it's undefined. I'm going to add 2 to the other side. So I'm going to make it equal to 0, add 2, multiply both sides by x to the third, and then divide both sides by 2. Now there's only one that can do it. So if I want to do this, this is going to be the cube root of 2, which is irrational. Make sure I did that right. So the cube root, oh wait a second, 2 divided by 2 is 1. Haha. So it's the cube root of 1, and that's a good answer. That's 1. So we have 2 critical numbers at 0 and at 1. Do a number line for 0 and 1, and this is going to go into the derivative right here. So pick a negative number. Remember, the cube root of a negative number is negative. So if I put in -1, you get a negative and a negative, so that's negative. Put in 1/2 and see what the answer is. So 1/2, the cube root of 1/2 is small, but when you do the reciprocal, it's going to make it big. Subtract 2. So that's why it's positive. And then pick another number bigger than 1, and it's going to create a big fraction. Like if I did the cube root of 1 billion, that's going to be a fraction, and -2 will be overwhelm the positive part, so that you definitely have a negative, positive, negative. So already we know where our relative max and relative minimum is. So at 0 we have a minimum, and at +1 we have a maximum. Come back here, 0 gives me 0, and +1, 1 to any exponent is 1. So 1, 1 is my maximum. So I have 0, 0, and 1, 1. Now I need to take the second derivative to find the concavity, the points of inflection. So here's my first derivative. So negative a third times 2 is negative 2/3 x. Subtract. So negative 1 subtract 3 is negative 4/3. And the derivative of negative 2 is 0. Again, a critical number is 0 to look at because it makes it undefined. So we have negative 2, and then this is x to the 3, x to the 4/3. So nothing makes it 0. So the numerator, nothing will make it 0, but what makes it undefined? So a critical number here is 0 because it makes the second derivative undefined. So if I did a number line with just 0 for the second derivative, this is the first derivative. So for the second derivative, just 0. So if I plug in negative 1, the cube root of negative 1, this is going to be a positive answer because of the even exponent, but it's negative here. So it's a positive times a negative. If I plug in, both sides are going to be negative. So if I plug in positive 1, I'd still get a negative times a positive. So both sides are negative, so that means there is no point of inflection. Make sure I have all the parts that they're looking for. So find concavity. Okay, so that means the entire. So from negative infinity to positive infinity, it is all concave down. So it's concave down, and here are the turning points. So it said find the extreme points and the concavity, and we did it. And then are we supposed to graph it again? Let's see. Oh, and graph it, of course. Let's graph this. So let's take the points I know. So the points I know are 0, 0, 1, 1, and that's it. And then think of what's going to happen here. So if I put in a negative number, so first of all, it is decreasing. Remember, this is my road map here. Let me put the road map here for my graph. So for the first derivative, it's 0 and 1, and it increases and then decreases. And then my road map for the second derivative is that it's concave down everywhere. So there's my road map. So I know that it's decreasing with a frown. So it decreases with a frown. And then, remember, the derivative does not exist. So it's going to be a cusp or corner at 0. And then it increases again with a frown. And that's a low point, and that is a high point. And you did it. So there's the graph using calculus tools. So concave down throughout, the derivative doesn't exist, and you have a low point and a high point, and you put it all together. All right, number 12. There it is. All right, just a bunch of basic derivative problems. So now it's going to get easier. So for number 12, can you take the derivative of that? So I can tell you how I would make it look, and then take the derivative. So I would write that to the exponent -3, and then do the power rules. So that would be -3, x squared minus 2x, subtract 1 to the exponent, and then the hook that comes at the end, the derivative of the base, which is 2x minus 2, and it's done. Number 13. In number 13, you have f at x equals the square root of x cubed subtract 3x plus 2. Again, I'm going to write that to the exponent 1/2, and then take the derivative using the chain rule. So take the radical sign, write it to the exponent 1/2. So the power rule, subtract 1, take away 2 is -1/2. And then it needs the hook of 3x squared minus 3. Done. Those are both examples of the chain rule. 14. Is an example of the quotient rule. That would be the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. I'm not even going to simplify that. So the derivative of the top is 1. That's why you don't see anything there. 15. In number 15, you're given a function and asked to find the inverse. So to find the inverse, we're first going to switch x and y. That's the definition of inverse. So we switch x and y to find the inverse and then solve for y. So we're going to add 1 and do the cube root to get y by itself. So that's the inverse right there, the cube root of x plus 1. So you add 1 and then cube root. If I graph both of them, the first one, the x cubed subtract 1, is you would start at -1 and then do a cube root. So it's a cube root been shifted down 1. Here, we're going to shift it to the left, -1, and then it's a cube root. So this is a cube function. Cube root function kind of looks like this. And then it reflects over the line y equals x. So again, the inverse was the cube root of x plus 1. And then the function was x cubed minus 1. So we have the function and its inverse on the same graph. And they reflect over the line y equals x. And I just did a transformation. I took the cube root and went down 1, or cube function and went down 1, and took the cube root and went 1 to the left and just sketched it. Number 16. Use a graphing adjustment of a parent to graph that. So the parent of that is 1 over x. And the graphing adjustment where x plus 1 means it's been shifted 1 to the left. So if I was going to graph this, I just got to shift everything 1 to the left. So you shift it 1 to the left to get 1 over x plus 1. So normally the point would be 1, 1, so 1 to the left. And it would normally be -1, -1, 1 to the left. And then our asymptotes, we still have 1 at 0, but everything else is 1 to the left. So it's at -1. And then you just draw it. So everything's just been shifted 1 to the left from 1 over x. All right, last one, number 17. So number 17, use the graph of the first derivative. I know these are challenging. That's why we got to practice them. So I'm going to do a first derivative number line. I want to know when the derivative there, when it's equal to 0. So that's at 2, and it goes from -2 to 6. I always forget that. -2 to 6. So when is the derivative equal to 0? So at 2 and at 5. And then above and below. So it's above, then it's below, and then it's above. So I did a first derivative number line. I'm going to do a second derivative number line from -2 to 6. So now I'm looking for turning points, or where the derivative is undefined. So at +1, the derivative is undefined. There's actually a line and then a slanted line. The derivatives don't agree. It's like a sharp corner. So from -2 to 1 is just the slope, and the slope of that is 0. So from -2 to 1, the slope is 0. From +1 to 4, you have a negative slope of -1. And then from 4 to 6 is a positive slope of 2, up 2 over 1. And just know that at 1 and at 4, the derivative doesn't exist at 1 or 4 because of the sharp corners. All right, so this is what I have so far. So I have my roadmap to my graphs. So it matters which one we want to graph first. So this is going to go from -2 to 6. Why don't we start the second derivative? So this is the roadmap. These are all horizontal lines. And at 1 will be a hole. So from 1 to -2, we have a hole. Whoops. From 1 to -2 is a horizontal line at 0. So that shows the slope is 0, and there's a hole here. From 1 to 4, it's -1. Holes on both sides. So it's undefined here and here. So the slope is 0, the slope is -1, and then the slope is 2. And here just shows where it's undefined, the derivative. So horizontal lines to represent the slope at each part. All right, how about the graph of the function now? And again, it goes from -2 to 6. And does it give you a starting point? No. So no starting point, so we can pick our own starting point. But we have a roadmap here. And so the roadmap is it increases and then it decreases. So it's going to go up and then down. So I'm going to pick a point at +2. And what I know is that wherever it is, it's going to increase. And I know it is the second derivative So the first one is 0, and then it's negative, and then it's positive. It's for concavity. So the first part is just going to be a line because it has no concavity. So from -2 to +2, it's increasing with a line because there's no concavity. It's 0. Then from 1 to 4, so wait a second. So from -2 to 1. From -2 to 1, it's a line. From 1 to 4, it's going to be concave down. So there's a curve here. Let me just show it. There's a curve now to 4. So we have a line, has no concavity, and then it's going to be from 1 to 4, it's going to be concave down. And at 2, we have a maximum. And then at 5, we have another, at 2 and 5, it's going to turn the other way. And it's going to be smiling. So let's make sure we did the roadmap okay. From -2 to +2, it's increasing. From -2 to 1, it's a line. And then it's concave down. From 4 to 6, it's concave up. And make sure we have increasing, decreasing, and then increasing so it matches. That's it. I know these are challenging. So I know you're following and copying, and there'll come a point you'll get more and more confident with these kind of situations. It's okay that it's challenging, and we'll get through and get stronger and not quit and figure this stuff out. Mr. G Math over and out, and until next time. I'm proud of you.